First of all, yesterday we had done some assignment questions. Anyway, the most important topic that we wanted to share today is the merge sort and the quick sort implementation details continued with the details of recursion, how the function calls are happening and what is the time complexity. Once you are able to understand how recursion is applied, then obviously time complexity analysis become easier. So let's get started with the merge sort algorithm first. Before getting to the code part, let me quickly revise the pseudocode because it's been almost a gap of 10 days now. So let me explain the approach. And for all of you, anybody is having any doubt in the merge sort, you can just type in chat. Let's get started. Okay. So in merge sort, what we were thinking is, let's say, for example, you are given an array. Let's say 1, 4, 2, 5, 6. 1, 2, 3, 4. In merge sort, we'll be using divide and conquer. Yes, DAC approach. So what we are going to do, every time we are going to divide this into two halves. Now, how is that division happening? First, we'll calculate the mid index. Now, mid index is like every time when you are executing merge sort, right? You will be getting a what do you call the start index and the end index of the array. Now you will be thinking by default, every time the start and the end will not be 4 and 0. But here in the first call, the start index is 0 and end index is 4. But when you call the merge sort for this first half, the start will be 0, end will be 2. And when you call merge sort for this second part, your start will be 3 and 4. So let us see how that part is happening. First, for the entire array, when we call, initially the first merge sort call that happens, because it is a recursive program. So here it will be start plus end minus start by 2. So this is basically 0 plus 4 minus 0 by 2. Now tell me guys, why do we do start plus end minus start by 2? Why don't we do start plus end by 2? Why don't we write mid equals to start plus end by 2? Anybody knows the reason why we are not doing like this? Yes. Nobody? Any guesses? Yes, no, anybody knows? Guys, can you be please more little bit more interactive? बच्चे ये टॉपिक है इंटरव्यू में हर जगह यही पूछा जाता है. मैथमेटिकली आर द सेम. ओके, मैथमेटिकली तो सेम है, लाइक एवरेज है. नहीं सेम है. रीजन क्या होता है? द रीजन इज वेरी सिंपल. Let me show you this reason with a playground example. One second. Let me open Google. Let me tell you why that we cannot do start plus end by 2. For example, let us take two variables, A and B. Zoom in. When we find mathematically, they are same. Why can't? Very good. Now see, let's say int A equals to 2. Now int B equals to integer dot max value. How many of you know what is the meaning of this integer dot max value? Tell me guys. Anybody has seen this integer dot max value? Don't know. Okay. Now guys, for every class in Java, let's say for example, integer data type is having a class, right? Then one second. Long is having, one second. Yes, long is having a class. So for every class, every data type will be having maximum range values will be there. That means whatever bits are available to int, for example, here int variable will have how many bytes? Four bytes. 4 bytes. So how many bits will be there? 32 bits. So the number possible with this 32, maximum number will be possible with this will be 2 power 32 minus 1. Yes or no? So that value will be stored here. So if I just print and show you system.out.println b. Let me show you what is there. See, can you see this? So this is a maximum integer value that an int variable can have. Now, once you have this, if you want to get the maximum value for any data type, for example, long is there. Let me write long, C, long dot. For long also, there will be something called max value. So for all the data types which can store numbers, we'll have a maximum value and min value both. Min value also I will show you. Let me print and show you. See. Now, why are we understanding this? Because this can possibly cause overflows in your arithmetic calculation. Can you see, guys? This is the first value is for the integer maximum, and the long variable can have maximum this number. So that is why when you want to store larger numbers, you prefer to use long data type. Now, is this making sense? Why, when we to take long or when to take int, right? Right now, similarly, when we were writing int b equals to max value, right? There is something called min value also for everything. So let me quickly show you that also. Then we will move on to the overflow exception that these values can cause. See, this is a negative value. Okay, now let's say, anyway, this long and all, you can leave it. Now what I will do, I will say int c equals to a plus b, and then I will print. Can you see, guys, why this answer is coming negative for C? But it should be like 214748369, because b plus 2 will be what? Some number with the ending 49, right? But the answer is totally negative. This is not expected. Now, what is the reason? Let me explain on the whiteboard. But this term, what phenomena we have seen here, this working is called overflow has happened. Your number has overflowed the container. So let me go there. So what happened? We had something like maximum value here, a plus b. C was having this. Now C also has 4 bytes. Now this number b, we had taken max value. That is 2 power 32 minus 1. Now we are telling plus 2. So definitely whatever the answer is, the answer will be something like this. This requires 33 bits. But in the answer where C we can store, it has only 4 bytes, that is 32 bits. So how can I store 33-bit solution in 32 bits? So what they will do, out of 33 bits, 32 bits they will store and 1 bit they will leave. Now because of this 1 bit that is left, the answer changes. Because when you take only partial bits and convert to decimal number, that corresponds to some other number only. Now what has happened? That means 1 bit has overflowed here. We tried to store it, but there was no space to store it. So this is why that overflow has happened here. And our answer is not as expected what we were thinking. So that is why. whenever you are adding two numbers and storing in the same data type, that should be avoided. Now here you could have used long. See, that was an ideal data choice. Now see, this is not a compilation error. So as a developer, it is your responsibility to come and check like which data type has to be used here. Now tell me guys, is this phenomena that whatever has happened here, is it clear, like the flow? It's a very common question, like what is overflow? You will not get any error, you will not get any exception, but still your answer will be wrong. So let us go back and let me write long. Now see, now also it is getting c equals to minus. So what you will have to do? You can actually write into 1L into 1L. Let me see. Now it is correct. Now guys, why we are doing 1L? Because effectively we know that we are going to store the answer in the long variable. Now when you take A and B as integer only, immediately, like when the bit addition takes place, the Java tries to store in int data type only and then put it in the long. So if you don't put this 1L, this 1L is basically converting A and B into long variables. You will still get a negative answer. See, still that problem will not go away. So what you have to do, you can write into 1L. This is 1L, that is first long variable. This is a way in which you can convert any int into long or any other data type into long variable. So this is a correct implementation. Okay. So anyway, this was relevant to our merge sort only at the point of mid and start, that mid calculation. So with this knowledge, let us go back to our merge sort, what we were thinking. So we had taken some array 2, 1, 4, 1, let's say 6, 7, 0, 1, 2, 3, 4, 5. So we call merge sort algorithm. In this, first we'll be passing the array address, starting index, and end index. Now every time when you will get, you will check if start is less than end. Why start is less than end? Because this indicates that there are more than two elements, at least more than one element in the array. Why? Because we have to stop at the point that when we get only one element. Yes or no? When we get only one element, we can stop at the algorithm. So what we will do? If there is at least two elements are there, that is more than one, then what we can do? Int mid equals to start plus end minus start by 2. Fine. Then what we will do? We will call merge sort. Recursively, we will call merge sort for the first half. What is the first half? ARR start to mid index. And what is the second half? We will write merge sort ARR mid plus 1 to start index. After you have sorted the first and the second half, then you will say merge. Merge both the arrays. What do you mean by both the arrays? From start to mid and the end part also. You need not pass mid plus 1 because that we can calculate in the merge algorithm. Tell me guys, is this pseudo code clear to everyone? ये बच्चे हमने लास्ट क्लास में भी पढ़ा था इतना, यहाँ तक everyone is up to speed till here? Then shall we go and implement this merge algorithm? कैसे implement करते हैं उसकी डिटेल कोड के साथ करेंगे. Okay, then let me share my screen here. So let us quickly, we'll be taking the input from the user only for everything. So let me write a scanner class. Okay. So let me quickly write scanner system.in. First we will take how many variables are there. Scan.nextInt. And then we'll declare the array. Now we'll write for int I equals to 0, I less than n, I plus plus, ARR of I equals to scan dot next int. Now we will call merge sort for the first time here. So we'll write ARR, we'll pass start index will be 0, last index will be n minus 1. Fine. Now since we have called this, after this we'll print the array also. Let me copy this loop. Now we'll go and define. Now, since I want this to be like this merge sort function to be used without creating an object, so I have used static keyword here. And this function is not returning anything. So return type is void. Now we'll write merge sort. We'll write int ARR, int start, int end. Now we will check if there are more than one element. Then what is the condition? Start less than end. And then we'll write int mid equals to start plus end minus start by 2. This is clear till now. Now we will, let me scroll down. Now we'll call merge sort recursively for the first half. So for the first half, index will be starting index is same, ending index will be mid. Now for the second half, we'll write merge sort ARR, and the starting index will be mid plus 1 because mid is included in the first half only. So mid plus 1 till end. Now after that, we have to write the code for merging two sorted arrays because till now first half will be sorted, second half will be sorted. Now we have to merge them. So we'll write merge sort ARR start mid, because where it was divided, that point will be giving by the why we are passing the mid information. And end. Now we will be writing the merge algorithm. So we'll go there. We'll write public static void. Now see beta, in merge algorithm, you can write a code in the way which you are going to return the array with the everything merged together, or you can do one thing in the existing array itself, you can try to replace the elements such that in the existing array only you are replacing everything and creating the swapped merge array. Are you, please explain the condition start equals less than end. I'll explain when we go to the whiteboard. This is to identify basically the array which you are getting is at least having more than one character, one element, because if only one element is there, that array is considered to be sorted. So we don't want to divide any array which is having only one element, and that is not possible also. Okay, tell me guys, do you remember the first algorithm we had done when we are getting two sorted arrays and we were trying to merge them into one array? Everyone remembers that? Yes or no? Last Saturday we would have done that. Yes? Okay. Now we are going with that information only, that approach is only going to be used. Only thing is we are going to put the elements answer in our original array only. So don't worry if you are not able to recall also. Step by step we will go here and then I'll explain. See. So let's say first I will take the array. Here we are getting int start. Here we are getting int mid and int end. That's it. Now we have to create two arrays, like the first array which is sorted and the second array, means first half, second half. So we will, first of all, let me calculate how many elements are there in the first half. So this will be what? Mid minus what do you call start plus 1. Now why it is there? Let me write an example here so that confusion is not there. Let's say this was the array 5, 6, 1, 2, 4. Let me write the indexes on top. 0, 1, 2, 3, 4. Now here let's say mid was what? 2. 0 plus 4 minus 0 by 2. So that is 2. So in your first part of array, starting will be what? 0. Ending will be what? 2. Yes. Ma'am, if we create a new array written by void, we using no. If you are returning a new array, then int you will have to write instead of void. Int bracket for indicating array. So here, beta, how many elements will be there? N1 will be equals to what? 0th index element, 1 index element, 2 index element. So how do we get 3 elements are there? So how do we get mid minus start plus 1? Why? Because indexing are starting from 0. That is why we do plus 1. Is this clear, beta? This calculation is clear to everyone? Please repeat from line number 31. I will repeat. See, when you are calling merge sort for the first time, right? When you are calling merge sort for the first time, that time what will happen? Here, merge sort will become. Main function will be executing. Let me copy this on the whiteboard, then we'll complete the function. Let me. So here, see, let's say you have taken the input and everything. You are calling the merge sort from your main function. Now here, let's say 5 elements were there. So you are passing 0 and n minus 1, 4. So here array comes, starting index is 0, ending index is 4. Now we calculate mid. Mid is what? Tell me, mid is what? 2. How? 0 plus 4 minus 0 by 2. Yes. So we say, okay, merge sort. Here it will be 0, 2. Here it will be 3, 4. Then we call merge algorithm. Here it is what? 0, 2, 4. So when we call merge algorithm, here the start value is 0, 2, end index is 4. Now I want to calculate how many elements are there in the first half. 0, 1, 2, 3, 4. So I say this will be your first half because this is the mid and this is your second part. So how do we get n? Because I want to create a new array for this and then I will merge them into single array, sorted array, right? Because this part will be sorted by merge sort. This part will be sorted by merge sort. So here it is what? 2 minus 0 plus 1, 3. 3 elements and yes, 1, 2, 3. 3 elements are there. Tell me guys, is it clear now? Yes or no? Yes. Okay. Okay. Then we will go back. Then similarly, now right now, we have created only got the size of only first array. So let us say, let me write down. Let's say this is the size of left array. Left and right terminology you can use, or you can use A1, A2, whatever. Left and right, let us use. So we say left equals to new int and n1 elements are there. Then we have to calculate the elements in the n2 also. The size, it will be, this will be simple. End minus mid. So if you just check here, end was 4 minus mid 2. So 2 elements are there. And that is also correct. Why? Because index number 3 and 4 element will be there. This 3 and 4 index will be there in the second. 2 elements. That is correct. So let me quickly declare the right array equals to new int n2. Perfect. Now, once you have done this, we will copy from the original array because see right now 2 arrays we are creating for our ease of implementation. So we'll write for int I equals to 0, I less than n1, I plus plus. So left array we will fill with the data. So we will write left of I will be equal to, what is the name of original array? ARR. And here, see what we will write. Start plus I. Why? Because for your array from which you want to copy, every time from the place where you are going to copy will be from the starting index in the left part of the array. And you cannot write directly I because this is a recursive call. Every time the start value will not be 0. It can be anything. When we do the dry run, you will see the start value will be 2, 3, something else also can be there. So you remember you have to write start plus I, not I directly here. Okay, then we will fill the right array. So we'll write int j equals to 0, j less than, how many elements are there here? N2, j plus plus. And then what we'll write? Right of j will be equals to ARR. And here what we will do? Here we will say mid plus 1 because the second array starting index is mid plus 1 and plus j. This is the reason. Now you have got right and left arrays with the elements. Now because merge sort was getting called recursively, the elements in the right and left you can assume that they will be sorted. That is the beauty of recursion here. Now only task left is to merge them properly and form a resultant array that is sorted. Now we will take two indexes, I equals to 0 and j equals to 0. Now, better see, even though you have used this I and j in the for loop again, you can declare them separately again. Why? Because the I and j created in the for loops, they are only available inside the for loop, not outside. So you can, on line number 48 and 49, you can redeclare I and j. Now you will take one more variable, int k equals to, let's say 1. Why we are taking 1? It depends upon the implementation. You can take anything else also. Now we will write our good old algorithm for merging. Here I will put the condition like I less than n1 because this will be the pointer for the first array and j less than n2 because this will be the pointer for the second array. Now we will check which is the element smaller. How we will check? Left of I less than or equal to also is okay. Right of j. If this is the case, then what we will do? We will say ARR of k. And this should not be 1 actually, this should be start. Yes, ARR of k equals to, which is the left of I. Okay. Now, since you have taken the element from the left index and the left array, and the index was I. So what you can do here? I plus plus. Else, what you will be doing? ARR of k equals to right of j. And then you say j plus plus. Because from the right side you have taken, so j plus plus. After this, you will have to do k plus plus because regardless of whatever you are doing, in the array which you are placing in ARR, there one element is placed either from the left array or right array, so k has to be increased. Now, after this, what we will write? We will just check whether anything is left in the left array or in the right array. So you can write something like this: while I less than n1, you can write ARR of k equals to left of I and I plus plus k plus plus. Similarly, if anything is left in the right side of the array, sorry, j less than n2. Remember guys, don't forget to change the n1, n2. These things are usually left. Sometimes if you miss it, your program may not run properly. And then here you convert to j plus plus. Okay. Now we have checked for both the sides and that's it. And since we are placing in the original array only, so we need not return anything from here. Ideally, this should work. Let us see whether, let us give some input and see if it is working correctly or not. Let me give some 5 numbers, 5, 4, 3, 2, 1. And let's see if any compilation errors are there. No. So okay. So can you see, guys? It is sorted. After merge sort, we have cleared it, right? Now tell me, guys, which part of the algorithm you want the dry run with more focus? Which part? I am planning to do the entire questions dry run once. You can tell me if anything is clear, then we can skip that part. Let me quickly. Yes. Okay, let me remove the white spaces so that this program can come in one go. Merge part will explain. Yes. So let me, yes. So let us, I will copy from here, this merge sort. I can do one thing. 1 second. I can copy parallelly. ठीक है, जितना विजिबल है उतना करते हैं, उसके बाद देखते हैं. Okay. Now let us take one array. Total reverse array ले लेते हैं. 5, 4, 1, 2, 3, 1. Let's say इतना लेते हैं. 0, 1, 2, 3, 4. Now, when the first time your algorithm will be called, the start will be 0, end will be 4. Now we will calculate mid. Mid will be 2. Now we call merge sort. From this first call will come. So if I write shortcut here, ARR 0, 4. Now inside this, one merge sort function is called from ARR 0 to 2. And then second merge sort call is called from ARR 3 to 4. And then we called merge algorithm from ARR 0 to 4. This part is clear, beta? How this function call I have written here? That's the representation. Yes, these 3 steps I have written. Okay. Now see, guys, I want you to show you like how recursion is helping you in this program. When as soon as Java sees this first function call, it will stop this. Remember in the recursion, what will happen? This will be, these 4 function calls will be in your function stack. Now this will be executing. So what is this? Merge sort ARR 0, 2. So here start will be what? 0. 4 will be there, but here new ending will come 2. So now mid will be what? 1. So inside this again merge sort ARR 0 to 1 will come. Then merge sort ARR, what do you call? 2 to 2 will come. And third merge algorithm ARR of 0, 1, 2 will come. Now, as soon as Java sees this function call, first it will execute this. So here it will be merge sort ARR 0, 1. Now here it will come. So mid will be what? Mid will be 0. So first call will be merge sort ARR 0, 0. Second will be merge sort ARR 1, 1. Third will be merge sort ARR 0, 1, 1. Okay. Now guys, as soon as Java sees this call, it will execute this. But remember, when it comes here, start will be also 0, end will be also 0. So it will not enter this. So no new function calls will come. This will be the ending condition. Here what will happen? Why this is there? Because in the array only one element is there. That is starting is also 0 index 1. So that means only this element is there. So it has divided, and last part is having only 5 element. Tell me guys, are these recursive calls clear? How that recursion is stopping? Why we have put start less than end? Everyone in the class, बच्चे किसी को भी doubt है अभी पूछो. Yes or no? Everyone in the chat, yes or no? There are 51 students on this call. What is happening? Why? Why no? Yes, no, nothing is coming. Yes. Okay. Now, so the importance of having the condition start less than end is clear to everyone. Okay. Now we will go to the execution part. So this is how, now one more thing I want you to focus here is, see beta, for every merge sort call, can you see? Sometimes the start is 0, end is 2. Sometimes the start is 3, end is 4. Sometimes the start is 0, 1, start is 2, end is also 2. So different values are there. And keep this in mind when we are going to apply the merge part of that. But by these recursive calls, you can assume that when you reach this step, these two calls would have completed. The above two calls are completed. That means your first half of the array and the second half of the array are sorted. Recursion would have taken care, because see, so many function calls are there for this only. Similarly, for this, one new function calls will come into. So by the time these are completed, this function stack is empty, your first half and second half will be sorted. Okay, let me clear this. Then we will go to the merge algorithm. So here, let's see what is happening. Let's say one array is there, 5, 4, 1, 2, 3, 0, 1, 2, 3. When the merge sort was called here, so you would have got something like this: 1, 4, 5, 2, 3. Zero, 1, 2, 3, 4. And here start will be 0, mid will be 2, end will be 4. Now now when merge was called, this was the array. This part was sorted, this part was sorted. Now we will calculate first. N1 equals to 2 minus start plus 1, that is 3 elements. N2 equals to end minus start. So that is what end minus mid. That is what 2 elements. Perfect. Now we calculate left array. Left array, what we have? Let me create indexes 0, 1, 2. This will be 0, 1. This is your left. This is your right. Now here, let us see what is happening. Here we are telling I equals to 0, start plus I. Why? Because from the original array you have to copy. So start is here, end is here, and mid is here. Okay. Now first I value is 0. Now left of I equals to start plus I, matlab start plus 0 means 1. Similarly 4, 5. For all the values till n1. n1 value is 3. So till the time I value reaches 2, it will execute. Now here 2, 3 will copy. Fine. By using this. So by this step, we have populated our left array and the right array. Now we will apply our old algorithm, the merge part. We will take I variable for the left array and j pointer for the right array. And now we are going to merge. But remember, when you are merging, you don't have to create a new array. In your original array only you have to write. So here, when I write here, I say k equals to start. So where is k? K is here. Now I start comparing left of I and right of I. 1 less than 2. 1 less than 2? Yes. So what we say, we enter this if block. ARR of k equals to left of I. ARR of k equals to left of I means 1. Again, we will override. See, it will not check the original array, but it will just override blindly. And then I plus plus. Fine, I comes here. And since we are going outside, else will not be executed, k plus plus. So k will be pointing to next index. Now again we check left of I, what is it? 4, and right of j is 2. So 4 less than 2? No. So it will go to else part. Now we blindly copy ARR of k equals to right of j. So we blindly copy this 2 here. Then we say j plus plus. Why? Because we have used that variable. Now it comes out, it says k plus plus. So k will point here. Now again we go there. Now what happens? We check left of I. What is left of I? 4. 4 less than 3? No. So it goes to else part. We copy 3 here and j plus plus. Now k plus plus also happens. So k is also pointing here. Now after this, now what happens? J less than n2. This condition will become false because this has crossed the boundary of right side. And since there was AND operator, even if one condition is false, we will have to stop the loop. So what will happen? So we will it will go to the below part. Let me clear this. Here. So it will exit the while loop. This while loop will over. Now it will come. While I less than n1, yes, I is still 1, n1 is what? 3. So it is less. So we will say, okay, ARR of k equals to 4. We will overwrite 4. Then we say I plus plus and k plus plus. Now we will say, okay, still I less than n. Yes, so we'll copy 5 here. And I plus plus, I will overflow k plus plus. Now I less than n1, no, it is equal to n1 but not less than. Now we'll go to next while loop. While j less than n2, no, it has already overflowed. So if you see your array would have become like, what is it? 1, 2, 3, 4, 5. 0, 1, 2, 3. See guys, is it clear, beta? How your merge algorithm is working? It is just overwriting, just like your merge function, picking the smallest element and putting into your original array. Yes or no? Is it crystal clear to everyone? Okay. Now, if this algorithm is clear, let us understand how the time complexity of merge sort is calculated. So for that, what I will do, I will write the pseudo code here. I will write the pseudo code here and you will be telling me what is the complexity. So merge sort is something like this: ARR start end if start less than end, here end, yes, n log n, but why it is n log n? That is what we have to understand here. Very good, Shivam. That is the reason. Here. Now tell me guys, let's say what is happening? Let's say n elements are there. We are dividing into what? N by 2, n by 2. Now tell me, what is the algorithm? What is the time complexity for this? This will be the time complexity of n by 2 elements. This will be the time complexity of n by 2 elements. And here we are merging. Now, how much time complexity is there for the merge algorithm? Tell me guys, what is the time complexity for merging the two arrays? It will be order of n plus 1 plus n plus 2. Because two arrays. Now this n plus 1 plus n plus 2 will be n only. So order of n we can write. So if you have to calculate time complexity of your merge sort will be this t plus n by 2. Time complexity of other n by 2 plus order of n. Now this n by 2 also will be broken into n by 2 square, n by 2 square, n by 4, n by 4. And till what point it will be going on? Till the point we have only one element, right? Let me show you. Till the point only one element is there. That is, let's say k times we are dividing, say n power 2 power k. Till the time n by 2 power k equals to 1. So what we can say, n equals to 2 power k. We can take log both sides. This will be what? Log of n equals to k log 2. We can say k equals to log n by log k log 2. So k equals to log 2 base n. Yes. And every time when we are doing this, we are calling merge algorithm also. So what it will be? N into log n. 2 you can ignore, constant is there. So order of n log n. Yes. Tell me guys, is it clear or not? How the complexity of merge sort is order of n log n. Perfect. Now see guys, this was the entire explanation for merge sort. Apart from this, I don't think there are any other questions that can come from merge sort. Like if somebody is asking you to explain merge sort, first of all, they will ask you how to work, how you will explain divide and conquer, you will write the code, you will write the merge algorithm, then they will ask what is the complexity of merge algorithm, then merge sort, and how the merge sort mathematically, how can you can derive this, you can write. Now guys, this is a direct implementation of merge sort. I hope your assignment questions get active. Their merge sort questions will be there, which will be very easy. If you have understood the like complete approach, it will be very easy for you to implement also. Now guys, after this, we will start with quick sort, wherein we have to, I have to tell you about pivot element and partition algorithm. So we will go into that detail and then complete the quick sort also. Let us take a break of 5 minutes and then we will continue with the quick sort algorithm. Okay, so it is 10, 11:30, 11:35 because your automatic lecture gets over by 12:30. So let us stick to 5 minutes. Yes. Let us get started, guys, with the quick sort algorithm. Let us get started with the quick sort algorithm. Here. So in quick sort, there are three things that we have to keep in mind. It is also a sorting technique only, but only a different way to arrange elements. Here, first we have to know what is pivot element. What is the meaning of pivot basically? Then we have to understand something like partition. And then we have to understand the correct position of element. These three concepts, if we are able to understand, then quicksort algorithm becomes very easy. So first, let me show you by one simple arithmetic operation. Let's see. Let's say one array is given to you. One, I'll make it 10. Now tell me, in this array, let's say 0, 1, 2, 3, 4. The sorted format of this array will be like this. 0, 1, 2, 3, 4. Tell me what is the correct position of 10 in the array? Correct position refers to where it should be if the array was sorted. So for 10, this should be index number 4. So if we are able to find the correct position of every element, then we can sort the array. If we are able to find all the elements correct position. So this is what quicksort does. What it says, for every element, I am going to find the correct position of the elements. How? That they will say, okay, we will be choosing one element and then trying to find the correct position of every algorithm. So for that, partition algorithm gives you what it does. It does two things. It finds you the correct position of every element, or you can say position of pivot element. Now you will say, what is pivot element? See guys, any element that you select will be called a pivot element. In quick sort, you can select any element. Usually for our implementation, for our example, I'll be always selecting the last element in the array as a pivot element. Fine. And then I will apply partition algorithm. We will write the code for it and show you how you can find the correct position of every element. So what I will do, once I find the correct position of my selected element called the pivot element, I will put it there. And one more thing I will do. This will do all the elements that are smaller than pivot element. Smaller than pivot element, it will put on the left side of pivot. For example, let me show you. Let us take one better example. Let's say 5, 4, 3, 1, 2. 0, 1, 2, 3. Now, since we are thinking that we will be selecting pivot element from the ending of the array. So our 2 becomes pivot element. See guys, when you will see different implementation of quicksort, sometimes the people will be selecting pivot element from the beginning or randomly also, or from the ending. The implementation today we are going for our understanding purpose. We are always going to select the pivot element from the ending. This is the base understanding that you should have. Then what I will call partition algorithm. Partition algo. So what I will give? I will give 2 element. So it will search the array and it will find out that the correct position is, tell me what is the correct position? Correct index is 1. Right? So your array will be look like this, that 0, 1, 2, 3, 4, and your 2 will come here. But one more thing, this partition algorithm will help us. On the left side, it will place all the element less than 2. And here, all the elements more than 2. here. So what will be there? Some random order will be there. I am just writing for example purpose. Now what you will do, if you know that 2 is at the correct position, that means we can call quick sort for the left side and quick sort for the right side. Umesh will come to that, but first we will understand quick sort. Then after that I will tell you what are in place and technique, because if right now I introduce this concept, nothing will be clear. So tell me guys, can we apply recursion for right side and left side? Yes or no? What happened, right? Okay. So in quicksort also we are using recursion. Recursion is getting called for the left side, right side. And how we are creating this left side and right side? Using partition algorithm. And every time we call partition element, one element will be at its correct position, right? So let us go and write down this quicksort algorithm. Let us get started. And partition algorithm, how it works, let me explain with some better example. First, let me write the main steps, whatever discussed till now. Let us go back. Here. Let me delete this. Now I will make it to quick sort. So here I have taken just the input, and now we will be writing the quick sort. Let me write public static void quick sort and here see guys, whenever you are writing quick sort, what will be the ending condition for your what you call recursion? Tell me guys, low will start less than end. That same thing can be there, yes or no? Because till the point we have one or more element, then only we are going to cover, right? Okay. Now instead of just that mid calculation, we are going to call partition algorithm. That is the only difference here. So let me write start, end, end, and I will write if start less than end. And now we will say pivot index. Pivot index we will find out equals to partition algorithm. We are going to call this logic. We will write after 2 minutes. ARR. We will pass the start index and the end index. That's it. And partition algorithm will do everything. Now we will apply quick sort for the left half. This will be what? ARR of starting. One second guys, let me charge my system. One second, let me apply on the charging port. Yes, Pratik, definitely you can leave. If you are mock interview there, all the best. So see guys. Now here start, and then we will be passing pivot index -1. Basically, whatever elements are there on the left side. Here we will be writing ARR pivot index +1 till the end index, and that's it. That much if you write, it is okay. Now come to the part where we are going to calculate the partition part. How do we do that? So for that, let me explain. Let me copy this much and go to the whiteboard. See. So let's say when the first time this quicksort would have been called, we would have something like 0 and 4. And we call partition algorithm. So in partition algorithm, what it will do? First, it will select the pivot. Pivot will be what? Whatever is the last element. So what it gets? ARR of end. So that is what? 2. Yes or no, guys? This is what we have assumed, but this will work upon your type of implementation. Now I will take two variables here, two pointers. Here I will be there. That will be start minus 1. Remember, start minus 1. And then we will take j, which will be pointing at the starting. So basically, I want you to focus that one pointer is just before the starting and one pointer is at the starting. Now see, we have addressed that this is your pivot element. Now what I will do, I will at every time, I will compare the element here with the pivot element. And my aim is to find the correct position of pivot element, plus I have to move them to the whatever elements are smaller than 2 to the left side. So whenever I find any element which is what you call less than pivot, then what I will do? I will just swap it. Let me show you. Let me delete this from here. This code we will start writing. So let's say pivot is 2. J value is 0. I value is minus 1. And we are going to compare ARR of J less than pivot element. Now, what is J element here? 5. 5 less than 2? 5 less than 2? No. So we say, okay, if it is not less than 2, then again we will increment J. So what is it? 3. 3 less than 2? No. So now we say, okay, fine, move ahead. J less than 1 less than 2? Yes, true. So what we say? We will say that we want to swap. What we want to swap? I and J. So remember, I is still at minus 1. So we will say, okay, fine. We'll do I plus plus. Now guys, this part is slightly, it, it takes a while to catch up, but step we will do it multiple times. Just try to understand what is happening in this step. Don't worry about the pointers right now. So see, we will swap. Swap means just write 5 here and 4 here. Actually, we'll be swapping between ARR, between index I and J. And we will make it I plus plus. So that will be 0. And now J index was actually what? 1, 2, 2. So we'll swap. Fine. 1 come here, 5 here. So your array looks like 1 is here, 5 is here. Then again we will start comparing. J value becomes 3. 4 less than 2? No. No, this will not do anything. Now again, we will start. We will say now till J will be going till high minus 1. Why? Because at high index, pivot is there. High you can say, or start you can say what I think we are using end and right? So let me write end index. So this will go till end minus 1. Now, once you have done this, what has happened, beta? See, till in the beginning, we are getting 1. Whatever elements are there less than 2, they would have got. But we have to put your pivot element at the correct position. So wherever your I has stopped, your I is here. At the next position, you can put your pivot element. So 2 and 3, you can directly exchange. So your array after first pass will look like this. 1, 2, 5, 4, 3. 0, 1, 2, 3, 4. And your pivot and partition index will return this as a pivot index. 1. Now what we will do? We will be sure that all the elements less than pivot will be on the left side, and on the right side will be all the greater elements. So we will call quicksort for this part and quicksort for this part. Just tell me guys, just the approach is clear, how that implementation ij values are working. We will do multiple dry run. The approach is clear to everyone, yes or no? Okay, now let us take a bigger array. Again, try to understand. One more example we will take. So let's take, let me do 10, 5, 1, 20, 30, 2, 4. Let's say 7. 0, 1, 2, 3, 4, 5, 6, 7. Now, in this, let's say first time we call partition algorithm. So your pivot will be, your starting is 0, ending is 7. Pivot will be ARR of end, that is 7. And our I will be starting from -1, J will be starting from 0. So let us start. I. And why are we taking this I and J variable? So guys, I will be why we use two indexes is I is basically used to indicate ending of left partition. Okay, this is the reason. So that at I plus 1 point, pivot element should be put. After the left partition, all the elements, left partition contains whatever elements are smaller than pivot element. So after that, what we put? We put all the elements which are greater than pivot. So at I plus 1 index, your pivot element will come. Let us see with the values how it is happening. At first step, I will be -1, J will be 0. Now, every time when we take our J value from 0 to end -1, we check ARR of J less than pivot or not. If they are less than pivot, then swap between I and J. That is what we are trying to do. Fine, let's start. So J will go to here till 6 index it will go. So J value is 0 right now. So we compare. 10 less than 7? No. So J value becomes 1. 5 less than 7? Yes. 5 is less than 7. So what we will do, we will make I as 0. So yeah, I will point here. J is pointing here already. And now we swap between this and this. So your swapping will happen. So your 5 will go there and 1 will come here. Now what will happen? Where are we? Are we correct at the position? No, we have done the reverse beta. Let me undo. 1 and 10 के बीच में नहीं, 10 और 5 के बीच में swapping होगा. So 5 will come there. Remember 0 और position और iron के बीच में गलती से उधर कर दिया था. So इधर 5 आ गया, इधर 10 आ गया. Now what will happen? Again J plus plus. So we will say J becomes 2. What is the element? 1. 1 less than pivot element? Yes. Then again we will do swapping. Now I plus 1 will happen. So I will be pointing to here. And J is at 2 index. So I is here, J is here. We will swap. Fine. 1 will come here, 10 will go there. Now see, again, we will say J plus plus. So J will come here. 20 less than 7? No. Then J plus plus. 30 less than 7? No. Then 2 less than 7? Yes. So what is our J value here? 4 bhi ho gaya, 5 aa gaya. Now we will say wherever I is next, we will do. So we will say 2 page 2 and this 5 index. So 10 will come, go from here and 2 will come. So 2 will come here, 10 comes here, right? Now J value becomes 6. 4 less than 7? Yes. Now what we will do? I plus plus 20 and this. 4 will come here, 20 will go there. So we'll move So here 4 and 20. And then j value will be 7. So but it cannot be because j will go to n minus 1 only. So idhar tak hi jayega. So we will stop. Now once we stop this, we have to put the pivot. So I is where? I is here now at the ending of your left partition. So what we will do? We will swap the pivot element to the end of the partition. Yes or no? Because all the elements which are less than 7 are in the left, pointed by I index. Now what will happen? We will do I plus plus. Here 7 will come, here 30 will come. So this is your left, this is your right. Now there is one doubt. We will swap pivot with I when j equals to pivot. No. बेटा equality पे कोई check नहीं है और बस हमारा agenda ये है कि जब भी all the elements which are less than that, we have to move towards the left, and that is what we have done. Every time our agenda was whenever ARR of j is less than pivot, then we were swapping. Is it clear? And जो भी जहाँ पे भी आई था उसके बाद में अपने pivot डाल दिया. Because left part contains all the elements less than pivot. Is it clear or not? In fact, जो भी equal to भी होगा वो भी right partition में आ जाता है. How we are changing the position of pivot at the end, beta. Let me write the code for you. Then I will show you where that pivot position is there. Every time one at right position. Yes, you can consider that. Let me write the code for you. Maybe then it will become more clear. Let us write code and then again we will do the dry run. So where were we? We had written this quick sort part, and then we have to write the what do you call partition algorithm. Okay. Now tell me, what is a partition algorithm returning to you? Every time it is returning. J and right is clear, but swapping of pivot is not getting clear. No worries. So let me quickly share the code with you. Public static int. Why we are writing int here? Because this is going to return the pivot index for partition purpose. So we are going to write partition int ARR int starting index int end index. As soon as you enter the pivot index, you select your partition algorithm, you select your pivot value equals to ARR of end. And then you say int I equals to starting -1. Why? Because recursive program is there. So you cannot write 0. Right. Now what we will do? We will put a for loop. Because one by one we are going to compare. So we will say int I equals to what? Starting. Or you can say, sorry, I we have already used j. Start j less than equal to end -1. Why? Because end index is the pivot element. J. Now, if ARR of j less than pivot, then what we are going to do? Simple. We are going to say, first we are going to say I plus plus, because I will be running always one step behind. We will say swap ARR between I and j index. For swapping data, we will write a separate function. So let me just write the function name here. And once you are doing this, that's it. But after this, after for loop, we have to place the pivot also at correct position. So how do we do that? We know that I will be pointing the end of the left partition. So we can say swap in ARR at I plus 1 position and ending index. Why? Because at end index pivot element is there. And then you can return the pivot position. So at I plus 1 your pivot would have come. So we can return I plus 1. Right? Tell me बच्चे ये clear है? इतना step clear है? Got it? अभी एक बार हम dry run करते हैं. So code is very small for quicksort. Only the understanding, once you have to just pay a little bit more attention. Let us take this स्वैपिंग का कोड नहीं लिखा है, स्वैपिंग का भी लिख देते हैं, एक सेकेंड. पब्लिक स्टैटिक void arr, sorry, swap int arr int I int j, and you can int temp arr of I equals to arr of j, and arr of j equals to temp. तो स्वैपिंग का कोड तो ड्राइविंग करने की जरूरत नहीं है, इधर से ड्राइव करते हैं. And let me run it also before, so that we can eliminate any issues. Okay, this is working. Let me take some random input also. Okay, fine. Let's set. So I think this is all set. Okay, let's get started. Let us take one input. Zero, 1, 2, 3. So first time when the quicksort is called, we will say 0 and 4 is the ending. Now we call partition 0 and 4. 0 and 4. Pivot is what? 3. Now we'll say I equals to what? -1. J equals to what? 0. Now we check ARR of J less than pivot. Now every time when we are doing this, what we are going to do? We are going to compare. So ARR of J will be 5 less than 3. No. So J value becomes 1. 1 less than 3. Yes. So we go inside. I value becomes plus plus. So I becomes 0. And we swap. So between 0 and 1 index, we swap. So your I becomes what? Oh, let me let me cut and write. 5 goes here. Now we again say J value becomes what? 2. So what is 2? 4 less than 3? No. Now 3. 2 less than 3? Yes. So we go inside, we say I plus plus. So I value becomes what? 1. So between 1 and what you call 3, this swap happens. So 5 cuts here, and here it write 2, and here 5 is written. So your array becomes what? Your array becomes something like 1, 2, 4, 5, 3. Till now everything is clear. Now J value becomes what? 4, but it will go only till n minus 1, and n minus 1 is what? 4 minus 1, 3. So till 3 only it will go. As soon as J value becomes 4, it will stop. Now, once you have done for all the comparison between all the elements, we have to put the pivot element at the correct position. Tell me what is the ending of left partition at ith, right? I equals to 1, left partition is ending. Yes. So here pivot should come at I plus 1. So we swap, and pivot is where? At the end index. So we swap. 3 comes here, 4 goes there. So now what has happened? Your array is 1, 2, 3, 5 and 4. 0, 1, 2, 3, 4. So this is your left partition, this is your right partition. So we will apply quicksort again. So pivot index, what is returned here? I plus 1. I plus 1 is what? 2. So here 2 is written. Now quicksort, we are saying ARR for this part from 0 to 1, and quicksort, that is pivot index minus 1. Why? Because pivot is already at the correct position. You do not need to sort it again. Yes or no? So now tell me guys, how we are able to put the pivot element at the correct position is clear? Yes or no in the chat? Okay. So बेटा क्विक सॉर्ट अगर कोई पूछेगा तो बता सकते हो अच्छे से? Everyone is comfortable with quick sort now? Okay, now let us understand the time complexity of this. Very interesting analysis of quick sort, time complexity. Tell me, what is the time complexity of quick sort? What is the time complexity of quick sort? Same as merge? No. Case by case differ करती है actually. See beta, for quick sort, worst case time complexity is order of n square. But in normal cases, it can be considered O of n log n. Why it is n square? Tell me why it is n square. Because every time you are applying quick sort, effectively we are going to find out a pivot element. And when you calculate pivot element, so it can be either at the correct position itself. That is, for every place you are going to do swapping. So let me explain this. थोड़ा सा explain करते हैं इसको. Let us analyze इसके help से. यहाँ पे क्या हो रहा है? There are n elements. Reverse sorted. Yes, you're right. See बेटा, theta of n या कैसे order of n कैसे आता है? ये एक बार समझते हैं. See, whenever you are trying to, let's say you are trying to arrange in ascending order. Okay. Now, if you are like, let's say, if your element are arranged in some or this fashion. 1, 2, 3, 4, 5. Then what will happen? Pivot element will be this. This part will be sorted. Then this will be already there. Then this part will be sorted. Then here. Then here. Then this is right. At least theta of n तो हमें लग ही रहा है. मतलब n times for every element. Partition algorithm is called, right? Let's say your element was like this. 1, reverse order में 3, 2, 1. And this you are trying to arrange in ascending order. Now every time what will happen? This pivot will be there. So for all of them, you will move it here. Now what will be there? 1, 4, 3, 2, 5. Now again you will select. So basically alternatively क्या होगा? एक partition empty होगा. Like either left partition or left right partition will be empty. So effectively you end up doing for n elements, and for all the n elements you call the partition algorithm, plus you do the quick sort for one of the partitions. So it becomes n square at that time. But this process can be, in best case when you see, or you can say in average cases, this will come out to be n log n. Still quick sort is very much preferred because you can optimize this algorithm. Remember, when you are trying to search for this, you can apply binary search at time of insertion. But for that, we will have to study binary search. Then I will come back and show you how the time complexity analysis for every case of quicksort can be done. Now, guys, in this algorithm, what we have seen is 2 parts every time. 2 parts are created, left partition, right partition. In some of the implementations, you can create 3 parts also. What I'm saying is, let's say you are creating pivot index, right? Sometimes they create more partitions, 1, 2, 3, or even k partitions that are called k-way quicksort. Although that is not asked anywhere, but just for the knowledge, you remember that it is not essentially dividing into 2 partitions. Okay, now guys, there are few things which I want to cover. I think most of you, somebody had asked also. Whenever you think about sorting, what we have seen, let me quickly revise first for you. We had seen bubble sort. We had seen insertion sort. We have seen merge sort. We have seen quick sort. Tell me, what is the time complexity of bubble sort? N square, order of n square, order of n log n. Yes or no? Here also we are having order of n square, but you can reduce it to order of n log n. Yes or no? Tell me, guys, This sorting algorithms, each of this is clear. Along with that, in every sorting algorithm, you have something called stable sorting and in-place sorting. Now, first of all, we should understand what is the meaning of stable and in-place sorting. And every sorting can be classified whether it is a in-place or not, stable or not. Tell me guys, what do you mean by the term in place? What do you mean by the term in place? Just the English meaning. Tell me guys. In place, no extra space, yes. So when you let's say recent example, what we have taken like we did not take any extra space, right? So quicksort can be considered as an in-place algorithm, in-place sorting algorithm, because we did not create any extra array. Yes or no? Similarly, bubble sort, selection sort also we can consider. In merge sort also, when we had written the last merge algorithm, we actually did not create any extra space. Only for left and right we had created. So that can also be considered as an in-place here. So in-place is very simple. If you're taking extra space, then it is out of place sorting technique. If you're not, then it is in place. Apart from that, what is the other thing? We have something called stable sorting techniques. Stable sorting techniques. Now this is very interesting. For this, let me explain. Let's say you have elements like 5, 5, 2, 1, 3, 4. Let's say two elements are there. This 5 element is duplicate here. So for this 5, let me say 5a and 5b, just to indicate which 5 is there. Let's say if I apply sorting technique and your result is 1, 2, 3, 4, 5, A and 5B. First option. Second option, 1, 2, 3, 4. This is sorting in 5B, 5A. This will be called, the first technique is called stable technique. And whatever technique 2 is there, this is called unstable. Because the order of the elements have changed. If they are same, then the order else should not change. So first 5 is coming first and second 5 is coming second. But here in the second technique, what you would have applied, here first 5b is coming and 5a is coming. So this is called unstable sorting technique. Guys, you're getting the meaning of stable and unstable here. What is the meaning of, at least is that clear? Yes or no? Okay, now let us see whether your quicksort is stable or not. Guys, whether quicksort is stable or not. I'll explain why. See, let us take this example and apply quicksort over it. 5, 5, 4, 1, 2, 3. Let us make 2 here. 0, 1, 2, 3. So first pivot is this. We'll compare. 5 is less than that. No. 4 here. Here. So we'll compare. 5 will come here. 1, 5. So your quicksort will be 1, 2. Like this is 5A. This is 5B. So 5A has come here. 2, 4, 5A, 3, 5B. Right? After first call, your algorithm will be like this. Now your pivot will be this. Now what happens? Here it will come 1, 2, 4, 5A, 3, 5B. Now we'll compare from here. Now what is the comparison point? This was the comparison point. Here in this part, quicksort will be applied. We'll compare 5, 5A less than 4. Yes, so we will not, this is less than that. No, this is less than this. So what will happen? Here it will compare and 3 will go here. Now what will happen? Again, your quicksort will be applied from here. So basically, maybe in this case, it will come or not come, but quicksort in this, what will happen? It does not consider pivot elements actual position, because every time you are selecting from ending. So when you are swapping, when you're interchanging the position, there is no reference given to it. At least in bubble sort or in insertion sort, what happens? Sequentially it happens. So even if there are duplicate elements, the swapping will not happen twice. But in quick sort, depending upon the number of passes your array has gone through, the order in place in between order can change. So quick sort is not a stable sorting algorithm. Maybe I'm not able to take a right example, but quick sort is not a stable algorithm. Okay, guys. So let me before the session ends, let me quickly go to your assignment questions. Yesterday we were doing one assignment question, which we automatically the call got cut. Let me go to that. Yeah, I wanted to complete that once again. Let us go. Which is this one, right? Here, huh? कौन सा question था? Anybody remember the question number? Sum of large number, something like that. Here. ये वाला था. Here till here we had written. So in this, Acha, quick sort, everything is clear, right? We can start this assignment question. No inputs I am getting, so I thought, okay, that must be clear. Yes. Interview will ask the questions for any other problem. Beta, it will ask. अभी इंटरव्यू किस टाइप का है तुम्हारा उस पर डिपेंड करता है. नॉर्मली क्या होता है कि फॉर एग्जांपल इफ इट इज अ फर्स्ट और सेकंड राउंड, sometimes they will ask you about the algorithm details only, time complexity analysis only. Sometimes क्या होता है कि बिल्कुल स्ट्रिक्टली प्रॉब्लम सॉल्विंग बेस्ड होता है, तो इंटरव्यू विल गिव यू लेट्स से 45 मिनट्स का सेशन है, so they will give you one problem and they will expect you to come up with the optimal solution also. So it depends कि कौन सा राउंड है और कितने टाइम का है. और बट आई वुड एडवाइज यू शुड प्रिपेयर फॉर एवरी टाइप ऑफ प्रॉब्लम्स. सो ओके, बाकी मॉक इंटरव्यूज तो है ही, उसमें तुम लोग की काफी प्रैक्टिस हो जाएगी, तो ऐसा नहीं है कि तुम लोग अनप्रिपेयर्ड हो गए. मॉक इंटरव्यूज आर मेंट फॉर दैट. Now guys, what we were thinking here in this question, we have to take very large values, so we are going to use string for it. We were thinking of taking advantage of string here, so we'll say string next. Yeah. Now what we will do is character by character we are going to add. Let's say if I show you, let us apply the approach here. 1 2 3 4 5, this is A, this is B. Let's say 1 2 3 0 0 1 0 1 2 3 4, right? Now what we are going to do, from the last we have to add 4 plus 3. Basically from the last character of both of them we have to add. So what we can do, first we can find the length of A and length of B, and then we can start a while loop from the ending, right? So we'll see. Let's see. And here what we are going to do, we are going to take two variables. And for every time we'll be maintaining one carry bit is 0. And we are going to maintain one answer in string. Initially, it will be an empty string. So we'll calculate the sum. Int sum equals to int a dot char at. Remember guys, char at function. Everyone knows what is the meaning of char at function. Yes, very good. J minus 0. So your carry will be what? Carry will be sum by 10. And yes, each character sum equals to sum modulus 10. That's it. So what you will say? Answer equals to answer plus you can say string dot value of sum. And every time when you are writing this, plus carry you do. That's it. Now let me show you by just printing what is there. Solution is not complete, but let me show you what is there in answer after this. Let us enter 1, 2, 3, 4, 5. Here we can enter 1, 2. Some error is there, let us see. Line number 137. This is like infinite loop is there because we have not taken care of doing this I minus minus and j minus minus. Let me show you. See, 75 is there. But remember guys, 1, 2, 3 are missing. Why? Because your first shortest string would have over and your j would have reached the 0th index first. So your while loop will end. So what we will do? We will write one more while loop. While I greater than equal to 0, just like merge algorithm. That same thing. While j greater than equal to 0. And we will write something like this. To copy this and modify this. And here it will be a only. And that you can use this again. Now let's see. Now also one case is left. Let me explain this, but after running this part. Now can you see guys, the reverse answer is there. Yes, I will do the dry run also. Now what we have to do, we have to reverse it. So let me, and we have to remove the trailing zeros beta. So let me, no worries, let me do one thing. Instead of this, you can put here. I'm not sure whether you be, how many of you got this point or not, but I like take it using dry run. Instead of doing a full reversal, you can reverse by the time of concatenation also. Only trailing zeros you will have to remove. That is okay, we can do that. Okay. Now let me quickly do a dry run so that approach is clear, then we'll come back and run. So let's see. Let's say first string is 1, 2, 3, 4, 5, and B is 1, 2. So 0, 1, 2, 3, 4, 0, 1. So I will be what? I value will be 4. J value will be what? 1. Now when we enter this while loop, we calculate what? What is the value of 5 plus 2? So sum will be what? Carry will be 0. So here it will be 7. Carry will be 0. Sum will be 7. So when we do the answer, we add the value here 7. That's it. Initially sum was 0. So we have added here. Now we say I minus minus. So I comes here and j comes here. Now what we does? 4 plus 1. What is it? 6. Now we say, okay, sum is 6. Carry is 0. Sum is 6. Now